Hi dear students, today we are going to prove that root 2 is irrational. We have to prove that root 2 is irrational. So the first step is we should show that root 2 is rational, or we should assume that root 2 is rational first. That we will write now. First step is that we have to take root 2 as rational, then only we can prove that root 2 is irrational. Let us assume the contrary. Contrary means what we have taken? We have taken that root 2 is irrational, so opposite to that one, so we have to take that root 2 is rational. Contrary means opposite to the statement, we have to take that root 2 is rational. What I am highlighting now, this is important point. The first step we have to write that the contrary of what is taken as a question, that is root 2 is irrational, we have assumed that contrary of that root 2 is rational. Then next will be such that we can write it as we can find the integers like a and b. We have taken a and b as a integer, and b should not be equals to 0. B should not be equals to 0 such that root 2 is equals to a by b. Root 2 is equals to a by b. This is the second point, very important. In the first step, this is the second point we have to take like this. In this, one note will be there. The note is a and b are co-prime numbers. These are all co-prime numbers. That is, a and b have only one as common factor. Only one as common factor. So this is the second step we have to take. In first step, we can find that integers a and b is not equals to 0 such that root 2 is equals to a by b. It is very important. We have to take that root 2 is equals to a by b. Let's take once again. Let root 2 is equals to a by b. So next step is, in the first step, in that one I am taking third point or third stage, we can tell that one. Now squaring both the sides, we get what we will get? Root 2 whole square is equals to a by b whole square. That I am writing here. Root 2 whole square is equals to a by b whole square. So root 2 whole square equals to a square divided by b square. Here root 2 and square of 2, that will cancels each other, so we will get 2 only in left hand side. In the right hand side we are having a square by b square. That one I am taking in the this side. 2 is equals to a square by b square. 2 is in the numerator, nothing is there in the denominator, means we have to consider as 1. So cross multiplication we can take. 2 into b square, and that is 2b square equals to a square. That is the important point. As a equation we have to take that 2b square is equals to a square. So continuity of that one, 2b square is equals to a square. So shift 2 to right hand side, shift the 2 into right hand side. So we get, so I am showing the arrow mark 2 to right hand side. So we get, what is remaining there? B square will remain. B square is equals to a square divided by 2. Here we know that this is also one of the equation considering b square is equals to a square by 2. This step also take it as one equation, important equation. In this theorem we have to prove that root 2 is irrational. So next step I am writing, if a square divides 2, a square is divisible by 2, then a is also divisible by 2. According to the theorem you have learned earlier, a square divides 2 means a also will be divided by 2. Then we will write now a is equals to 2c. A is equals to 2c, but considering before that one, a square is equals to 2b. Already we know that, as we got, I have marked in the red sketch that we have taken here as a reciprocal of that one. A square is equals to 2b square, and a is equals to 2b, and a is equals to 2b, we can write it as, instead of b taking c, a is equals to 2c. Here c is any integer, c is the any integer. So this one is very important point here. Instead of b square we have taken c, instead of b we have taken c. So squaring on both the sides, what we taken now, no, a is equals to 2c. For that one, squaring on both the sides, we will get that a square is equals to 2c. A square is equals to 2c, 2c square. It means that both the sides we are squaring. So substitute the value of a, or equation what we have early, no, that equation we have to put there according to the theorem. So we have taken that 2c square is equals to 2b square. We have taken 2c square is equals to 2b square. Otherwise we can write it as 2b square is equals to 2c square. So what, 2 will get cancels each other? No. B square is equals to 2c square. If b square is divisible by 2, then shift this 2 to that side, so you will get b square divided by 2. Then b is divisible by 2. Here see the two equations, 2c square is equals to 2b square. Here 2c square we can write it as b square, and 2b square we can write it as 2c square. So at the final we will tell that b square is divisible by 2, then b is divisible by 2. Therefore a and b have at 2 as common factor. Here at least at the end what we can tell means a and b having 2 common factors, because it is a root 2. If root cancels means we will get the 2. So therefore a and b have least 2 as common factor. We will finally we can conclude that we are having 2 as common factor. Two numbers we are having common factor, and we should tell in the sentence form a and b have at least 2 as common factor. So next contradiction what we have taken early, that is the original question is the root 2 is irrational, but we have contradicted that root 2 is rational. That one we are writing again. This contradicts that fact that a and b have no common factor. Here we have to feel that a and b have no common factor. This contradiction we are taking now, not the originality. The contradiction we are taking that a and b have no common factor other than 1. Other than 1, if it is a co-prime numbers a and b, then it is a 1 is a common factor, but we are having here at least 2 as common factor, so this contradiction is false. So at the final we can conclude that this contradiction has arisen. This contradiction has as arisen because of our incorrect assumption. The incorrect assumption is what we have taken root 2 is rational. That is the incorrect assumption we have made, because we have to prove that root 2 is irrational. So we have taken the incorrect assumption that root 2 is rational. That is the contradiction we have taken. That only I am repeating. This contradiction arisen because of our incorrect assumption that root 2 is rational. Root 2 is rational. So at the end we conclude that root 2 is irrational. It is very important. We have taken that root 2 is rational first, then this is not proved here, so we are considering that root 2 is irrational. At the end we are taken as root 2 is irrational, hence we have proved this one. Thank you.